How can Marvel movie character Ant-Man produce such strong energy out of his small body? The secret lies in the transistors on his suit that amplify weak signals for processing. Transistors that amplify electrical signals in the conventional way lose heat energy and limit the speed of signal transfer, which degrades performance. What if it were possible to overcome such limitation and make a high-performance suit that is light and small but without loss of heat energy? Researchers from Korea and Russia jointly developed a nano-excitonic transistor using intralayer and interlayer excitons in heterostructure-based semiconductors, which addresses the limitations of existing transistors. Excitons are responsible for light emission of semiconductor materials and are key to developing a next-generation light-emitting element with less heat generation, and a light source for quantum information technology due to the free conversion between light and material in their electrically neutral states. There are two types of excitons in a semiconductor heterobilayer, which is a stack of two different semiconductor monolayers: the intralayer excitons with horizontal direction and the interlayer excitons with vertical direction. Optical signals emitted by the two excitons have different light durations and coherence times. This means that selective control of the two optical signals could enable the development of a 2-bit exciton transistor. However, it was challenging to control intra and interlayer excitons in nanoscale spaces due to the non-homogeneity of semiconductor heterostructures and the low luminous efficiency of interlayer excitons, in addition to the diffraction limit of light. The team in its previous research had proposed technology for controlling excitons in nano-level spaces by pressing semiconductor materials with a nanoscale tip. This time, for the first time ever, the researchers were able to remotely control the density and luminescence efficiency of excitons based on polarized light on the tip without directly touching the excitons. The most significant advantage of this method, which combines a photonic nanocavity and a spatial light modulator, is that it can reversibly control excitons, minimizing physical damage to the semiconductor material. Also, the nano-excitonic transistor that utilizes light can help process massive amounts of data at the speed of light while minimizing heat energy loss. Artificial intelligence (AI) has made inroads into our lives more quickly than we ever expected, and it requires huge volumes of data for learning in order to provide good answers that are actually helpful for users. The ever-increasing volume of information should be collected and processed as more and more fields utilize AI. This research is expected to propose a new data processing strategy befitting an era of data explosion. The nano-excitonic transistor is expected to play an integral role in realizing an optical computer, which will help process the huge amounts of data driven by AI technology.